Hey everyone, this is just a quick reminder on how to factor using the AC method. These are the problems that I've posted for week 1 on Monday, and I just wanted to go over 3 different examples that would help you complete them if you've forgotten how to do them. So if we look at our first problem, we have x squared plus 9x plus 14. We're trying to factor it as completely as possible, and the first thing you always check for is a greatest common factor. If there is a greatest common factor, you factor it from all of the terms in the expression first. Otherwise, you move straight into a times c. Now, there's no greatest common factor on our first one because this 14 doesn't have an x, and the x squared doesn't have a constant in front of it, a coefficient besides 1, so there's no GCF for us to do anything with. So we move into the a times c method. In order to do this, we multiply our a value and our c value. Our a value is the invisible 1, our c value is 14, so 1 times 14 is 14. And we're going to list all the factors of a times c, and we're looking for our magic numbers, the ones that add together to our middle term, to our b value, which is 9. When I list these factors, I always start with 1 and the number, so 1 times 14, and I move up. I ask myself, does 2 work? Yes, 14 is even. So I have 2 and 7. And I stop there because 2 plus 7 is 9. Those are my magic numbers. Now, my a value is 1, which means I can use my shortcut. I don't have to split my middle term into 2x and 7x because my a value is 1. So I have my magic numbers. All I'm going to do is plug them into the factored form. So I have x plus 2 x plus 7. And that's it. That's all I'm looking for in the problems that I've posted for you today on Monday. This is the easiest type of problem because everything's positive. Things get a little bit trickier whenever you have negatives. Like our second example here, x squared minus 6x minus 27. For the regular students that I have, in the problems I did post that chart that's normally up on the blackboard, on the whiteboard, telling you what factors should be positive and negative. I don't have that here, so I'm going to explain it a different way, but if you use that, make sure you're looking at it whenever you're working through these problems. So, first thing to do is check for a greatest common factor. There is no greatest common factor among these 3 terms because 27 does not have an x, which means there's no variable that's in common, and the coefficient of my leading term is 1, which means there's no number GCF besides 1. So we don't worry about it, and again, we're going to be able to use our shortcut because a value is 1. We do a times c, which is negative 27. And we are looking for the factors of negative 27 that add together to negative 6. Now, because the sum of these factors is going to be negative, because my b is negative, that means, I don't know if y'all can hear that or not, but if there's like a bouncing sound or a crashing sound, that's my son who's upstairs in a bouncer. So, that means that the bigger factor is going to have to be negative. If b is negative, my bigger factor is going to be negative. So when I start listing these factors of negative 27, looking for the ones that add together to negative 6, I'm going to make sure that the first number, which is 1, is going to be positive, and the second number is going to be negative. So 1 and negative 27, those don't add together to negative 6, so I move on. I ask myself, does 2 work? Well, 2 doesn't work because 27 is odd. 3 does work. 3 is a factor of 27. 3 and negative 9. And those are my magic numbers because 3 plus negative 9 is negative 6. Found my magic numbers. All I'm going to do is, like I did in the first problem, use my shortcut. So I have x plus 3, x minus 9. And I'm done. That's all I'm asking for. This is the fully factored form of this expression. Then we come to this problem. This is like number 4 in the problems that I gave you for today. The first thing you check is if there is a greatest common factor. In this case, there is. Now remember, GCF always happens in 2 parts. You first think about the variables, and then you think about the constants and the coefficients, the big numbers. There's no variable in common because 40 doesn't have an x, so I know my GCF is not going to be 40. And then if I look at my coefficients and my constant, I'm looking for the greatest factor that they all have in common. And I look at the smallest number, the 4, and I ask myself, which of the factors of 4 are also factors of 44 and 40? And the answer should pretty obviously be that 4 is something they have in common. So I'm going to factor out a 4. I pull it in front of a parentheses, and then I start dividing. I fill that parentheses by dividing out a 4. 4 divided by 4 is 1, so I'm left with just x squared, because I didn't mess with the x's at all. 44 divided by 4 is 11, so I'm left with plus 11x. 40 divided by 4 is 10, so I'm plus 10. And from here, I factor using a times c. I factored out the greatest common factor, and now I'm going to factor using a times c. And the reason we want to do that is because I now have an expression with a value of 1, which means I can use my shortcut. And so the factors of 10 that add together to 11, I'm not even going to list them out because the first one is the one that works. The factors of 10, you start at 1 and 10. 1 plus 10 is 11. 1 and 10 are my magic numbers. So I'm left with 4. X plus 1, x plus 10. And that's my final answer. You can't forget this GCF. It has to stay out in front. But yeah, this is just a review on how to do this. That's all I'm expecting from the first 4 problems that I've posted. Hopefully this was helpful. Please do these problems and let me know if you have any questions.